Hi all, hope you are doing well. Today let us understand about the basics of power distribution in electrical industrial electrical panels. So for that again we need to go back because the size of this drawing is too big to accommodate in that presentation. So this is one of the project that I was working there as a design engineer. So let us understand the power distribution in this project. So there was three substations. The SS meaning of SS is a substation. SS 61, SS 60, and SS 45. So there were three HT panel. So this is one HT panel. This is another HT panel, and this is another HT panel. So look at here. This what it is written. The arrow showing that side is purchaser scope, and arrow showing this side is contractor scope. This dotted line that is called battery limit. So where the contractor's scope starts. Similarly, here also dotted line purchaser scope, contractor scope, and here also same thing, dotted line purchaser scope, contractor scope. So it says that the contractor scope does not include the HT panel, but it includes cable. This is the symbol of cable. By now, I think you know the termination there and whatever is there downstream. Now, so for this project, so we had power from three substations, and from there, for example, from 61, the power. These are the cables as entered into this dotted box means the panel. The name of this panel is PMCC 08. Similarly, from SS60, from this HT board, uh, many of the PCC has been supplied. Power has been supplied to many PCCs. So if you count the number of feeders, like one, 2, 3, 4, 5, 6, 6 on this side, and 1, 2, 3, 4, 5, 6, 6 on this side. So there are total 12 feeders, outgoing feeders, 2 incomers, and 1 bus coupler. Generally, this is the structure in any projects, but there can have lot of variations into this. There may be one incomer, so in that case, no bus coupler is required, or in this case, there is only one bus bar, but there are options for double bus bar system. So those those variations are there. Now let me tell you on this thing that there are six feeders. Let us say on the bus A, this is called bus A, and let us call this bus B another six feeder. If you look at the architecture, let's say this PCC2 has two incomer. So this is one incomer one. This is incomer two. Let's say so. Incomer one has got power from one side of this bus. Sorry, incomer two has got power from another side of the bus. This is done for the redundancy of the power supply. And remember this always. This if there is a two incomer system, so both the incomers will get power supply from two different bus, two different bus bar. Now it means what? There are six and six feeders, so there will be six numbers of PCC. So this is HT board, and from that HT board, the power is supplied to the PCC, Power Control Center (PCC). Right. So there will be six PCC. Right. This is PCC one. This is PCC two. PCC3, this is PCC4, this is PCC5, and then this is PCC6. So six PCCs are done. Power has been supplied to all these six PCC, and from the PCC, it is going to either to the motor through the VFD and SST. VFD or SST. SST is soft starter, and VFD is variable frequency drive. And other outgoings are going to like MCC and PDB. So MCC is motor control center, PDB is power distribution board. The difference is outgoing of the MCCs are going to the motors. So these are the symbols. So now let us zoom into an one MCC. This is the symbol of intelligent controller. This is the symbol of R doll, means reverse doll. I have already shown you the scheme drawing of R doll. This is the symbol of doll. This is the symbol of R doll again with intelligent controller. This is called dual doll, means both these motors will start together at the same time and will also stop together at the same time. Generally, these contactors are kept side by side with a mechanical locking system. And if you look into this is PCC. From the PCC, power is supplied to uh, one is PDB, one is MCC, and one is MLDB. MLDB is what it is called? Main lighting distribution board. So plant have its own lighting system. So for that we need to give power. That power is supplied through MLDB. PDBs are generally they are not the motor feeders but other utility feeders where powers are required. For example, it can be welding socket. Now, what is an welding socket and how it operates? The network of welding socket we will discuss in a separate video. So, again, the power is supplied from the HT board to this PCC to from the PCC to MCC, MLDB, and PDB. So, this is the structure. If you look into others like PCC 2, same thing has happened. From the PCC 2, uh, MCC2 and PDB2 has got the supply. So that is how it is distributed. Now let me tell you one more thing. So this panel is called PMCC8. So what is the difference between PMCC and PCC? So if you look at the PCC, they are all power feeders. There is no motor feeders. Now we will say this: there are motors, but these motors are getting supplied from their VFD or stop starters. So there is no starter inside this panel. They are all power feeder. If you are not getting this clear, kindly comment in the comment box. I will make a separate video what I am trying to tell. But in case of PMCC, this is called power and motor control center, which means it has power feeders. Like, see, it is then UPSDB. It is going to the UPSDB. So there are many places where uninterrupted power supply is required in the plant, and for that we need to give a power supply to the UPSDB from where it will go to the UPS and outgoing distribution of the UPS. Now let me tell you the difference between PMCC and PCC. The PCC is power control center, means they are providing power only to the power feeders, whereas PMCC provide power supply to both power feeders as well as to the motor feeders. So these are the motors directly supplying from the PMCC to the motors. So they have their intelligent controller and all. Okay, so one more thing I wanted to tell you, this doll, where I have seen this dual doll. So let me show you this PCC one, MCC one. So this one. So if you look at it, every motor do have their own individual intelligent controller. But here there are two motors, but it is showing one uh, intelligent controller. This is not correct. There should have two different intelligent controller. Every motor should have their own intelligent controller. Always remember this. If you are going to work as an design engineer, this configuration won't work. This intelligent controller will not capture any of the faults correctly, because combining those two motors is, I mean, overloading also won't be able to set. So the bottom line is this configuration is not correct. You need to take two separate intelligent controller here. I think that is what I wanted to tell. Now, let me show you what is a PCC and their SLD. For that, let me go here. Okay, so that's how a PCC looks like. All the components that we have seen in the, that is called overall SLD, that I was describing by now, here, right? These are called vertical. These are, sorry, these are called verticals. So, and they are generally numbered as like 1F, 2F, 3F, 4F, 5F, 6F. So there are six vertical in this PCC, and this is the breaker. It is an ACB, and these are meters. These are selector switch, and this is a TNC switch. This particular switch called pistol grip switch. It looks like a pistol in older Hindi movie you might have seen. So let us see the GA drawing. So this is the GA drawing of that particular project that I was showing. This is how the GA drawing looks like. So that's, as I was saying, that this 1F, 2F, 3F, that is how the verticals are numbered. And this is a front view, and the below is, sorry, I was just trying to, here's a pointer, right? So this is the front view. This view is called front view, and this is the top view. This top view is very important to build the foundation. So this becomes an input drawing to the civil also, and for the guy who will prepare the foundation structure at site. Okay, one more thing is that look at this curved line here. This curved line indicates a, this is called break line. Right? So it means this PCC is, the drawing is not complete here. It will be continued. Also look at these uh, sizes. So even though different manufacturer do have their own way to calculate the size, but manufacturers like Siemens. So we can. This is not a Siemens drawing though, but I'm just telling out of my experience that we can standardize the sizes for calculating how many feeders are required, and each feeder contain how many verticals are required, and how many feeders are to be accommodated in a particular vertical. For example, in this vertical 2F, there are uh, two feeders, right? So that way, from a load list given to a designer, one can calculate that how many verticals, how many feeders are required in a particular PCC, so that they can size the dimension of that PCC or MCC, and that size is found from here only. For example, this ACB require this much of size, right? You can get it from here. This is 1600, this is 900 something, so if you minus it, so you will get some size. So that is the size of an ACB, whatever rating, 4000 rating ACB, that is the size. So we are getting a size. From this size, I'll discuss about it from means how to calculate the dimension, GA drawings, etc. from load list in a separate video. But just to give you a brief idea about how the designers do this calculation. So once we are getting this size for all these all these different feeders, so definitely we are going to get this size of the enter vertical and the enter panel. Okay. So this is the middle section of the panel. Again, this is the brake line. This is the brake line. So, and this, oh my God. Okay. So end portion is miss. So end portion is something like that. There will be brake line here, but there is no brake line here. It is just an end line. That's how it is. Now let me tell about this SLD of that particular PCC. So this is the SLD, and as I have shown you in the beginning of this slide, that there are components in front of the PCC. So these are the components. The SLD will show you these are the components are going to be there. These are all these are the symbol of LEDs, the lamps that will be there. This is a timer. These are all relay, under voltage relay. Then this is a switch. This is master trip relay. These will be there in front of the that incomer. This is annunciator, hooter, and selector switches. Right now, this is the outgoing SLD of the outgoing. This for this particular PCC in the outgoing, there will be this on off trip circuit, healthy trip indication. There will be a switch. There are ammeters. I think this is multi-function meter MFM, and this is a selector switch. So these are the things will be in front of that panel. I think this is enough for today's video, and I'll come for MCC and PDB, PMCC. The structure of PMCC and PCC is more or less similar. MCC do have a little bit different GA drawing, and I'll come to that in subsequent videos. Thank you.